So, welcome to this session. Today we go to see one-dimensional heat equations. So, these are the content of this unit. So, today we go to one-dimensional heat equations. The one-dimensional heat equation is nothing but dou U divided by dou T is equal to alpha square into dou square U divided by dou x square. So this is the one-dimensional heat equations. So solve the one-dimensional heat equation. So we will get three possible solution. So these are the three possible solutions. So in these three possible solution, we go to choose which one is the proper solution for solving one-dimensional heat equations. So based on the situation, so we go to choose equation. So solution 2 is the most suitable solution for solving one-dimensional heat equations. So that is u of x comma t is nothing but a cos lambda x plus b sin lambda x into c into e power minus a square lambda square t. So now type 2. So already we discussed type 1. So type 1 is nothing but, so let us consider a bar. So one end of the bar is capital A. So another end of the bar is capital B. So the point of A is nothing but x is equal to 0. Here x is nothing but L. So let us consider the length of the bar is L. So here theta 1 is the temperature for the particular point A when x is equal to 0, and theta 2 is the temperature 2 at the point B when x is equal to L. Suppose both the ends are 0 degrees Celsius. So theta 1 is equal to 0 degree Celsius and theta 2 is also 0 degree Celsius. Therefore, this comes under the case of type number 1. So now we go to see the type number 2. So type number 2 is nothing but both the ends are non-zero. So this is also non-zero degree Celsius. Theta 2 is also non-zero degree Celsius. Both the ends are non-zero. That is given. Non-zero temperature at end point of the bar in steady state. So, then we know to the most important term is steady state. Steady state is nothing but independent of time. Before we go to start the counting, so therefore independent of time is not dependent here. So after some time, so it will be reaches to, after some time, the non-zero term will be reaches to 0 degree Celsius both the end. So then we call as a zero temperature in unsteady state. Once it reaches the 0 degree Celsius in the both the ends, then steady state will be converted into unsteady state. Okay. So now in the, if the steady state temperature u of x comma t is a function of x alone, so as independent of t. So suppose it is in the case of steady state temperature, so u of x comma t will be independent of time. Therefore, it will be act as u of x only. So when it is in the steady state condition, our u of x comma t will be act as only u of x. Now you go to differentiate. Now you go to differentiating this u of x with respect to t. So therefore, dou u divided by dou t is equal to 0. Since it is independent of t, therefore differentiation of u is 0. So therefore, dou u by dou t is 0. So from this result, we know that one. So what is our one-dimensional heat equations? So dou u divided by dou t is equal to alpha square into dou square u divided by dou x square. Therefore, since dou u by dou t is 0 means, so 0 is equal to alpha square into dou square u divided by dou x square. Therefore, bring this a constant term on other side, which implies we know that one dou square u by dou x square is 0. So therefore, since the second derivative is 0 means, therefore we'll get u of u is equal to x plus b. How it comes means, so that is take integration on both sides. Integral of, so dou square u divided by dou x square is equal to, so 0, integral of 0. This is nothing but, so dou by dou x of dou u divided by dou x is equal to integral. So integral of 0. So integration differentiation get cancelled. you will get dou u by dou x is equal to a. So again we will get this. Again you go to integrating once, we will get integral of dou by dou x of u is equal to, so integral of a. So integration differentiation get cancelled. U is nothing but ax plus b. So this result we will get. So then u is nothing but, so theta 2 minus theta 1 divided by L into x plus theta 1. So instead of using these results, so we will get this concept. Okay. So the steady state changes from steady state to unsteady state. So the temperature or ends are reduces to 0. So when it is changes from steady to unsteady state, so therefore both the ends are 0. So we have to use either this result or this. So anyway, both the results have been similar. At the time of solving problem, I explain this concept, how it comes, how which one we have to use. So how it will be reduces your time to solve the problem. So the boundary conditions. So non-zero temperature at the endpoints of the bar in steady state and zero temperature in the unsteady state. So the boundary conditions are u of 0 comma t is equal to 0 and u of L comma t is equal to 0. So both times should be greater than 0. So both the ends are 0, both the temperatures are 0. Then u of x comma 0 is equal to f of x. So for all x lies between 0 and L. So here also algebraic form. Hereafter on in type 2 and 3 it is f of x should be only algebraic form. There is no trigonometric form. So problem number 1. So a rod 30 centimeter long has its ends A and B kept at 20 degrees Celsius and 80 degree Celsius. Therefore, this is, so to take a rod. So one end of the, let us consider this, both ends are A and B. So here x is equal to 0. The length of the rod is 30 centimeter. Therefore, this is 30. Here theta 1 is nothing but 20 degree Celsius. So theta 2 is 80 degree Celsius. So both ends are non-zero temperature. So until the steady state condition prevails, so the temperature at each ends are suddenly reduces to 0. So after some time, so both the ends are reduces to 0. That is theta 1 is equal to 0 degree Celsius and theta 2 is equal to 0 degree Celsius. So both the ends suddenly reduces to this case. Okay. So take x is equal to 0 at A. Find the temperature at a distance x from the A at any time t. So after we will to find the what is our u of x comma t in this situation. So solution. So our one-dimensional heat equation is this. So solve this, we will get three system of equation. We go to choose the one suitable solution. So this is given. So what is already we discussed. So rod is given, one end is A, another end is B. Here x is nothing but 0. Here x is equal to 30. That is actually we are choosing length of the rod is 0 to L. Here L is nothing but 30. So here at present initially, so theta 1 is equal to, so 20 degree Celsius. So theta 2 is equal to, so 80 degree Celsius. So that is the initial steady state condition. So when x is equal to 0, when x is equal to 0, our temperature is 20, our temperature is nothing but u. So when x is equal to 0, which implies our u is equal to 20. So that is given. So when x is equal to 30, our temperature is at present, what is the temperature point B? It is 80. Therefore, when x is equal to 30, which implies our u is nothing but 80. So that is given here. So in steady state u of x comma t is independent of time t. So for functions of x. So u is equal to theta 2 minus theta 1 divided by L into x plus theta 1. You can replace theta 2 and theta 1, will get this point. Okay. So already we discussed u is nothing but, so ax plus b. So that is nothing but u of x. So when x is equal to 0, so u of 0 is equal to, so a into 0 plus b. So 1 and first end. When x is equal to 0, what is our u of 0? U of 0 is 20. Therefore 20 is equal to b. So b is equal to 20. So we need to find a. So when x, our next point is when x is equal to 30. So u of 30 is equal to, so a into, instead of x we go to replace 30 plus b. So what is our u of 30? U of 30 is nothing but 80. Here we know that u of 30 is 80. So that is nothing but, so a into 30. Already we know the result, b is nothing but 20. So bring this 20 on the other side. So 80 minus 20 is 60 is equal to 30 into a. So which implies a is nothing but 2. So therefore replace here. So we'll get 2, 2x plus b. U is 1, 2x plus b. So see here, instead of L, if I replace the 30, so this is nothing but 2x plus 20. Okay, here b is nothing but 20. Okay, anyway we go to solve these two system of equations, so we will get the same system, same solution. So that's why instead of that one we go to utilize this u. Anyway you have to solve, use this formula, or you can use this way. Okay, you can solve this anyway, the final solution is similar. Okay, so either how to utilize this means we go to find a and b, replace in a and b, you will get the same solution. So otherwise directly you can replace your u, will get this same solution. So which one you have to feel easier, you have to use that part. No need to use both the cases. Any one you have to show is enough. Anyway, finally we go to see what is our equation. Okay, so now, so this is our u of x comma 0. So in this problem I go to keep L as it is L. As the final result I go to replace L is equal to 30. So these are the boundary conditions. So this is our f of x actually. Our f of x, the initial u of x comma 0. U of x comma 0 is nothing but f of x. That is f of x is nothing but 60 by L into x plus 20. So u of x comma 0 comma t is equal to 0 first condition, u of L comma t is equal to 0, that is second condition, and your u of x comma 0 is f of x. F of x is nothing but this part. Okay, so the most suitable solution is a cos lambda x plus b sin lambda x into c into e power minus alpha square lambda square t. Here your a, b and lambda are constant term. Okay, we want to determine this a, b and lambda. So now we got to apply this condition number 1 in equation number 1, this condition. So condition number 1, I go to apply this equation number 1. So what is this? Instead of x we go to replace wherever x is there, here it is x, here it is x and here it is x. So instead of x I go to replace 0. So you will get u of 0 comma t is equal to a cos 0 plus b sin 0. So cos 0 is nothing but 1, sin 0 is 0. So b into 0 is 0, 0 plus a is a. C will be here. Okay. So c into e power minus alpha square lambda square t. So since this part is non-zero, so let us consider, so a into b is equal to 0 means either a is 0 or b is 0 or both are 0. So both are 0 means there is no solution. So either a is 0 or b is 0. So now here we go to take this, either a is 0 or this exponential term is 0. Sir, here we denoted since this is non-zero. Why this is non-zero means, suppose if our consideration this part is 0. Okay, suppose if it is this part is 0, so we know that one the solution is 0. So that's why we consider this is 0 means the 0 into anything, the whole thing tends to 0, or u of x comma t is always 0. So that is not possible. So since it is 0 means, so all the timings for all t the temperature is 0. That is not possible. So already we have some amount of temperature is there. So therefore, if our consideration this is equal to 0 is wrong. Therefore, from this we go to consider, so this is non-zero. Since this is non-zero, only possibility a is 0. So therefore a is 0. Now I go to replace a is equal to 0 in the previous solution. So here I go to replace a is equal to 0. So 0 into anything. So this term tends to cancel. So only b sin lambda x into c into e power minus alpha square lambda square t is the updated solution. So that is this b sin lambda x into c into e power minus alpha square lambda square t is the updated solution. So hereafter I go to apply the condition in the updated solution. So what is our second condition? Our second condition is u of l comma t is equal to 0. This condition I go to apply in your updated solution. So in that updated solution, instead of x, I go to replace L. Wherever x is there, I go to replace L. Therefore, u of L comma t is equal to b sine. This sine lambda x will be converted into sine lambda L. The remaining terms as it is. So u of L comma t is 0. So if it is 0 means here three terms are there. So one term is b, another term is sine, and another term is exponential. So already we discussed exponential is non-zero. Therefore, we don't bother about this. This is non-zero. So either b is 0 or sine lambda L is 0. Suppose if it is b is 0, so let us consider b is 0 means the whole solution tends to 0. Therefore, b is non-zero. Only possibility sine lambda L is 0. Therefore, here I go to consider sine lambda L is 0. So therefore, since sine lambda L is 0, bring this sign another side you will get lambda L is equal to sine inverse of 0. Therefore, sine inverse of 0 is nothing but n pi. So therefore, bring this lambda L another side we get lambda is equal to n pi by L. Now I go to replace lambda is equal to n pi by L in the updated solution. Instead of lambda, I go to replace n pi by L. So we will get this part. So b into sin n pi x by L, c into e power minus alpha square n square pi square L square divided by t. So here n runs from 1 to infinity. So replace, so b into c. B is a constant term, c is another constant term. So 2 into 3 is nothing but you will get another constant 6. 2 is a constant term, 3 is a constant term. So we will get another constant. Therefore, so b into c is nothing but I will take b n. So therefore here I go to replace n is equal to 1 plus n is equal to 2 plus n is equal to 3 and so on. So we go to add all those things. So I go to do in the most general solution. So go to this sum of that n is equal to 1, 2, 3 up to infinity. I go to take the sum. So remaining right as it is summation. This is our most general solution. So now, so I go to apply the third condition, second condition over third condition. What is our third condition? U of x comma 0 is equal to f of x. I go to replace wherever t is there, I go to replace 0. So here, so instead of t, I go to replace 0, we will get 0. So instead of t, here instead of t, I go to replace 0, the whole term 0 into anything is 0. Therefore, we will get e power 0. E power 0 is 1. Therefore, our u of x comma t is equal to f of x. Therefore, we will get summation. So, bn into sine term as it is, e power 0 is 1. Okay. So, now, so we go to the Fourier half-range sine series. Since it is algebraic term is there, so f of x is equal to summation here. Bn is nothing but small bn. I go to convert it. So instead of capital Bn, I got taken as a small bn. So summation n is equal to 1 to infinity bn sin n pi x divided by L. So comparing the above equation, we may conclude that bn is nothing but 2 divided by L integral 0 to L f of x into sin n pi x by L into dx. So this is the formula for bn. Replace our f of x. So then take the using the Bernoulli's formula, apply the integrals. So apply upper and lower limit, we'll get the final solution is bn. So after we got the bn, we go to replace that bn in your most general solution here. So instead of bn, we go to replace it here. So we'll get this part. So finally, I go to replace L is equal to 30. So that is your choice whether you have to replace L is equal to 30 here itself. Here itself, we can replace L is equal to 30. Or at final solution, we can replace L is equal to 30. That is your choice. Or initially, we go to replace L is equal to 30. Okay. So next problem. A rod of length L has its range capital A and capital B kept at a 0 degrees Celsius and 100 degrees Celsius until steady state condition prevails. So here, so one end is 0 degree Celsius and another end is 100 degree Celsius. Anyway, one side is non-zero. Both ends are 0 means comes under type number 1. So one end is non-zero. We will wait up to it will be reduced to 0 degree Celsius. So if the temperature B is suddenly reduced to 0 degree Celsius and maintained at 0 degree. So after some times it will be reduces to 0 degree Celsius. So therefore after some time means it will be in the unsteady state. So this is the one dimensional heat equations. So therefore when U x is equal to 0, first temperature U is 0. When x is equal to L, U is equal to 100. Therefore substitute your theta 1 and theta 2, we'll get our f of x is equal to 100 by L into x. So therefore these are the two boundary conditions. U of 0 comma t is equal to 0, U of L comma t is equal to 0. This is initial condition is U of x comma 0 is equal to f of x. So that is 100 by L into x. So this is your proper solution. So here we need to find what is A, what is B, and what is lambda. So therefore first we go to apply condition number 1 in this solution. So wherever x is there we can replace 0. So we will get A is equal to 0. So now we replace A is equal to 0 in the solution. So this term tends to 0. So therefore we will get this part. So now I go to apply condition number 2. So condition number 2, U of L comma T in the updated solution here. Okay. So I go to replace. So x is equal to L. Wherever x is there, I can replace L. So we will get lambda is equal to n pi by L. Now I replace lambda is equal to n pi by L. Wherever lambda is there, I go to replace n pi by L. So we'll get this solution. So next, the most general solution is this. Now I go to apply condition number 3. Condition number 3 is U of x comma 0. So wherever t is there, I go to replace 0. So e power 0 is 1. So this is nothing but f of x. Now I go to use this is of the form Fourier half range sine series format. So therefore I go to use the Fourier half range sine series formula. Capital Bn is nothing but small bn 2 by L 0 to L f of x sine n by x by L into dx. I go to replace our f of x. So now I go to take the integrations. We will get Bn is equal to this. Now we go to replace Bn in the most general solution. We will get this is the solution. So this is a problem for practice for you. So practice it, and once we will get the solution whether we receive. Okay. Thank you.